Section 4.3, example number 10. We've just seen a couple of strange examples where we had no solutions, and then another one where we had a solution in every quadrant. We've also seen some problems where we've been doubling or tripling the angle and getting more answers in the interval, right? This one is halving, and that's going to give us fewer answers. Let's go ahead and see what this one's going to look like. So tangent of x over 2 is equal to -3. Let's change that to x over 2 equals the inverse tangent of -3. That means, well, I can't think of any angles that I know of that make the inverse tangent -3. Not inverse tangent, but the tangent of what angle is -3. That's not one of the ones that we know, right? So we probably need to use a calculator, except that this says use exact solutions. Alright, well let's go ahead and solve for x. So this would be the answer that we get in quadrant 4, but there would also be an answer in quadrant 2. Right? So to get to that answer in quadrant 2, we're going to need to add values of pi times k. And that's because tangent has a period of pi, so it's just going to keep going from quadrant 4 to quadrant 2 to quadrant 4 to quadrant 2, and so we just add pi to get between those two quadrants infinitely many answers. Alright, so this, now we want to get rid of that 2, we're going to multiply everything by 2. So multiply by 2, multiply by 2, multiply by 2. So that would give us 2 inverse tangent of -3 plus 2 pi k. Alright, so that would be the exact answers for infinitely many answers. We just want the answers from 0 to 2 pi. If we plug in 0 for k, we're adding 0, and we'll get this answer that's in the fourth quadrant, negative fourth quadrant times 2. Well, we don't want our answer to be in the negative fourth quadrant, even though that's what our calculator would give to us. Sorry for the interruption. So I want the answers from 0 to 2 pi, right? So I need to plug in values for k and see what I'm getting. But I also need to leave my answer exact, which means I'm going to leave it ugly like this. So I've just got to think about what this answer is going to give to me. If I plug in a negative ratio, I'm going to get out a negative quadrant 4 angle. So adding 0 to that is going to leave my answer negative, which is not between 0 and 2 pi. So I need to let k equal 1, and so I'll have that answer, inverse tangent of -3 plus 2 pi. That will be a valid answer that will take the answer we get from quadrant 4, multiply it by 2, so now it's going to be even more negative, like in quadrant 3 negative, and then add 2 pi to it, which would put it in quadrant 1, right? Now because we're adding 2 pi each time, because this started with dividing by 2, so we have to add 2 pi to it to get to the next answer. K equals 2 is not going to make sense, because that would mean that we're adding 4 pi, which would take the quadrant 1 angle we just found, add 2 pi to it again, and take it back to quadrant 1 again. But that quadrant 1 answer will be past 2 pi, so that will be too big. So 2 tangent inverse of -3 plus 2 pi is our only answer that will be between 0 and 2 pi. One more if I have time before the bell rings and interrupts me. This time, it doesn't say we have to leave our answers exact. So we're going to do this one more like we did example 2. So 2x is equal to the inverse sine of 0.87. That's going to give me a quadrant 1 answer, right? But I also need a quadrant 2 answer. So for quadrant 2, we are going to take pi minus the quadrant 1 answer. However, we already have this 2x going on, so we may not need to do that at all. Actually, we will, because this will increase the number of answers one way. Okay, so we have 2x equals inverse sine of 0.87. So that's one possible answer, plus 2 pi k. And then quadrant 2 would be found by taking this answer, which is quadrant 1, which is also our reference angle, and subtracting that from pi. So that would be 2x equals pi minus inverse sine of 0.87. That gives me my quadrant 2 angle, and then that quadrant 2 angle for infinitely many answers would be plus 2 pi k. Alright, now to solve for x. So x would be the inverse sine of 0.87 divided by 2 plus pi times k over pi halves minus the inverse sine of 0.87 divided by 2 plus pi k. At this point, if we're not caring about exact answers, we should probably go ahead and find this decimal answer to start using. So this would be using my calculator, make sure I'm in radian mode, inverse sine of 0.87 to 5 by 2. So that part gave me 0.5276 plus pi k. So that would be that same answer there. So pi halves minus that. I'll just write it as pi halves for now. Minus 0.5276 plus pi k. Alright, so then we start letting k equal various numbers, and theoretically we should find 4 answers because of the double angle. Okay, so we've got 0.5276. And then to find this answer, I actually need to do this math. So pi divided by 2 minus 0.5276. So that is 1.0432. So 1.0432. Okay, now we're going to let k equal 1. So that would mean I'm going to take 0.5276 and add pi, which gives me 3.669. So that's a quadrant 3 angle because it's bigger than pi. And then this one here, 1.0432 plus pi is 4.1848. Okay, and then we could try k equals 2. So if I did 0.52, no, that wouldn't make sense, because if k equals 2, we're adding 2 pi. We're taking a positive number and adding 2 pi that's bigger than 2 pi. So these are our answers right here. 4 answers for our double angle, which makes sense. We need to leave those answers exact instead of approximate. This one and this one are pretty close, other than we would probably want to write them out as 4 separate answers. So we would have 0.5276. Oh yeah, those aren't the exact ones, are they? Go back. So approximate answers, blah blah blah. So then we have this So we could write that as 1/2 inverse sine 0.87, and that would be one answer. But let's get rid of that little extra bit. Okay, and then we would have pi halves minus 1/2 sine inverse sine of 0.7. Then we would have k equals 1, so that would be 1/2 sine inverse of 0.87 plus pi. And our last one would also be adding pi, because k equals 1, but it would be adding pi to our pi halves, so we could include it there. 3 pi halves minus 1/2 sine inverse of 0.87. So there's 4 exact answers, and here's our 4 approximate answers to 4 decimal places.